Hello folks, well today it's this Fidelity 1000 and this is of great sentimental value to its owner, so much so that he drove 200 miles to bring it personally and will do the same to fetch it back. So what he's got, why have I taken the lids off already? I had a radio club meeting this morning. You probably know I'm a member of the South Castilian Amateur Radio Society, and we had a meeting this morning, and in 2 sets time, because the next one after this is I mentioned this before and I can never remember, Colt 295A, and that's a trade one chassis. Then we've got this first, which is an end user, and then we've got an Audio Line 341 that only arrived today, and it had, I guessed from the description that it had capacitor issues, so that's going to form part of its video in 2 sets time. So that's the audio line. But I took the lids off this just to point out 1 or 2 things to club members. Not that they're necessarily interested in CB radio, but it's all general electronics, isn't it? So what we've got here is with no display, says the customer. I turned it on this morning at the club meeting, and indeed there's no display. So I'll tell you what, we'll power it up here. I may as well put it on 12 volts rather than 13.8, and we will see it not lighting up. There we are on 12 volts. I'm not putting an aerial on because we don't need to get that far. So as you can see, there's no display. So without looking at the circuit diagram, I'm presuming that there's no 8 volts kicking around. So unlike the Maxons and sets like that, this doesn't have a regulator chip for the 8 volt rail. It has transistors and the Zener diode, and the Zener diode can sometimes fail. So let's see. I can never remember whether these are a chassis that's floating or whether it's a live chassis. It's floating. So you wouldn't think that on what is, at the end of the day, a cheap set. It doesn't matter that I've got the wrong way. We'll use a coil as an earth point. We'll just check that again at the volume switch, and we've got 12 volts. So quick change of glasses. I don't want to leave this on long under fault condition, but normally what we're going to have on the case of the transistor, it looks like I've got nothing. Nothing. Wow, because I'm not switched on, what a fool. So we've got 8 volts there, rail voltage there, and 8 volts there. So it doesn't seem that we've got a voltage regulator problem here. Now, I've only got 10 minutes to make a start on this. I have 2 church services tomorrow, so I don't know what inroads we'd make tomorrow. We'll just open up this phase lock loop department. Chances are we're going to have to do the frequency anyway, if and when we get it working. Just pop the power off while we take that lid off. The reason it's sometimes got solder on these lids is because you can end up with microphony, and that's where it's so rattly when you're in transmit. You can actually hear it rattling as you drive down the road. So let's have a look in this department. Check we've still got connection to our meter. We have. Pin 1. 6 volts. I'm going to connect the aerial, because, and by that I mean to the test equipment. We'll plug the factory original mic in. It's not what I thought. Switch picture in picture on. Oh, we're on the wrong camera on the other channel. Let's go to the main one. There we are. Put it in the 3 watt range. Press transmit. And we've got, what's that, 150 milliwatts. Let's go to the full power. We've got 2 watts, bearing in mind we're at 12.5 volts. So it looks like, let's just put the camera onto there, 2776. 767. What? Move it up 3 channels. It is actually working. So the synthesizer is running. So it's actually a display problem. That's not what I was expecting. So if I count the channels, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Hopefully we're at 27,99125. And we are, but it's off frequency. And if I move it around once more, it should wrap round to channel 1, so it would be 27,60125. And it is. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Should be back to 27,79125, which it is. So it says there's no transmitted audio either. So we'll just go back to the main meter on this. 1, 2, 1, 2. Let's listen on our monitor receiver. Testing 1, 2. It feels like it's trying. I don't think that's an electric. I think that's a different fault. So I was thinking about a common denominator between the two. So have we got a dry joint? Have we got a burnt out resistor? Because that's I think what we're looking for. I'd hate to think if it's the ribbon cable that's failed. Let's have a quick look. I haven't got the circuit diagram out yet, so we'll see how we go. It's got fluff on it like a blown up capacitor, but I can't see any blown up capacitors. The channel selector has this separate board here, so one ribbon cable goes down to the phase lock loop chip on the main board. We know all that's working perfectly. So all that can't be working perfectly is between the display and this top board, or a component on this top board. So I think that what we're probably best off doing, I'll just turn the power off, is I think we'll start by going over this board with the isopropyl alcohol and look for dry joints. But first of all, see if that's one. just like blown up capacitor on it. And of course that might have happened, and it's been repaired, but the debris is still on here. Okay, power it back up. Well, I'll dig the circuit diagrams out. We'll get some isopropyl alcohol on there, and we'll take it from there when I come back. Alright folks, so I'm back for another short session. But all these short sessions can add up to a fixed set. So looking at the circuit diagram, we've got the original circuit here, and they published a phase lock loop section separately, which is here, and having printed this off, I don't think there's any reason to have printed it off. So you've got one end of the channel selector switches going down to chassis, or shall we say negative, because it's a floating chassis, isn't it? And then we've got the other end, which is going to be, if we look here, it's going to go to the regulator IC. IC, transistor in this. So, what with that side of the choke, now this voltage surely must be present, otherwise we wouldn't have, let's trace point F. Yeah, if that voltage wasn't present, the radio wouldn't be selecting channels, because point F also goes to channel selector switch for the actual phase lock loop. So this voltage must be present, so it's either missing its earth, or it's missing its positive from there. We've also got the redrawn circuit diagram, which tells us it's plus 8 volts. Okay, so when we look at the actual radio, with two wires go down to this subboard. We've got a green one and we've got a red one. Chances are the red one is our 8-volt rail and the green one is earth. So I'll tell you what, we'll put the power on. We're still at 12 volts, and we'll need to make sure that our negative prod goes to a negative point yet to be determined. Probably to the connector which our power is going to. We'll just put it on the negative crocodile clip. So we've got the 8 volts there. We've got the 8 volts there. So we have the power to the board. So how can it not be working? So the answer has to be, well, we can't have every resistor failed, so there's got to be a broken track or a dry joint. There has to be. So let's look at it from this end. I'll take picture in picture off. So we'll just try and find where these wires go again. So green there, red there. I think we're looking about here. That one, and that one. We've got our voltage on this board, so we have to have a track brake sure it's got to be at the negative end. Right, well, I'll investigate this further. Right, so I've taken the front off because the next thing's the display board. All you've got is two ribbon wires. But looking at this, the top wire has snapped off from the print's been snapped off for whatever reason. It's had pressure, I'm sure. And when you look at the front, it's had pressure and one of the lugs has broken off. Something's happened. Knocked their knees on it in the car in a crash. But that top wire has definitely snapped away. I think we've got to isolate that wire and then hand wire it to the actual pin. I'm sure that's where our answer lies. So, if you look at that, the broken track is now gone. Fold down where it snapped away, and I've swiveled it across to the pin that it appears to have come from. I don't have to recover one of these from a scrap set because there's a lot involved in that wiring. Switch it back on. So much for that idea. Let's see if we can find a scrap set down here to have a look at the way that should be. Okay, so we've got two of them playing up. So that one you saw me with the broken track, and I've linked it to there. This one at the bottom is also coming away, so I think the track is intermittent. So what I was finding is when I pressed on the display, it was operating, and then you kind of let go and wiggle it around and it wasn't operating. So I've run a wire to effectively reinforce the fact that the printed circuit track has died a death on that. So that should be a full cure. We'll have this set on overnight. Otherwise we've got to start buying in a scrap set. Helps if I replace the piece of insulation. I think we're going to put some extra insulation at that top, because the only thing that actually stops those from shorting out is that insulating tape. I think the only solution is we've got to find a scrap set and we've got to recover the channel display off it. It's not going to be reliable otherwise. Right, what we're going to do is carry on with the rest of the radio, and the fact the channel display is iffy, we'll deal with that later on. Let's see if I can find the service manual and whether we're going to remember it all. With my memory. Oh well, we'll see how we get on. So the phase lock loop is working beautifully, everything's in lock over the 40 channels, we've proved that. Look at that deviation control, it could be in the wrong position. So the problem with the display is solely down to the tracks on the printed circuit board, you know, and the shorting out. It's going to have to be replaced, and it's a horrible, horrible job. Right, there we are, we're on channel 20. Let's go through the transmitter. Picture in picture on. So go through this, we'll publish this video. We'll do an on-the-air test as a chassis probably. I'll think about what we're going to do later. But I'll just have to buy in another set if I can't find something around here. And as I speak, what's that? You know what? I've got one on the back of my bench. Yeah. There's actually one on the back of my bench. I think we're going to be... Do you know what? It'd be easier and cheaper Let's drag this out. Probably easier to detach that ribbon, and this one's had its display taken off, but that's a working display on this customer set. It's the board that's knackered. Anyway, we'll come to that. At least we've got something without having to buy it in by the looks of it. Anyway, that's just a display, that doesn't matter for now. Let's put it on full power, and we'll put the power supply on full power. I'll get a sheet of paper and we'll make it start. So, as the set comes, key it up. He's doing 2.6 watts on channel 20. And anything over 1.7 is acceptable. Channel 40. He's doing 2.6 watts. Channel 1. He's doing 2.65 watts. It's well balanced. On low power, pop it back to channel 20. It's doing it's doing 300 milliwatts. And back to full power, the current consumption at full power is only 660, it's 666, I'm not going to write that down. It's 667 milliamps. We don't have the devil's number, do we, in there? Deviation, I don't think we've got any. 1 to Warlow, no. Nil. In lock. Frequency, let's go over to the frequency counter. 2779102, because it's as the thing's warmed up. 2779102. Let's bring that up right now. It's the trimmer capacitor just there. I think we'll leave it at that. And we'll dial that into the signal generator. 2779142. What am I on about? 125. Okay. So we'll put the synad meter on. And let's see what we've got. So we know these are bleed over boxes. But they're very sensitive. And that can be the downfall. If I can find a pen, which is right there, let's put that up on the inset picture. 12 dB, and we've got 0.46. For 10 dB, 0.41, and for 20, 0.92. So that already passes anyway. Squelch is AM on these. There's its own AM detector to do the squelch. it is 180 microvolts. And we'll set threshold for the squelch. Let's see what we've got. Got 1 microvolt. Signal meter. And it's to get S9, it's 300 microvolts. That's somewhat lazy. And the RF meter, when we're going to transmit, and let's make sure we're on high power. So it's doing what did we say? 2.6 watts. It should be in the center. Oh no, it shouldn't be in the center of the red zone on these. It should actually be on the 4. He's telling about the truth, isn't it? It's about 3. So, and that's what the set's doing. The practice is that whatever the output is, you set those to 4, even if they're 2. It's just psychological. Part of the current models, as you're probably fully aware, are fake meters anyway. You can even take the output transistors out and they'll still bang across in transmit. The meter lamp works, the switches work, the potentiometers work, the one and only socket doesn't have that, and the mic, we don't know the mic works yet. We don't know. So that's a good start. Let's see if we can get something more out of the transmitter. So I'll show that on the inset picture. So we're in the centre. That needed a little bit of adjustment. That was already spot on. That needed a bit of adjustment. We're at 2.8 watts. Everything needed a bit of adjustment, apart from that one. Now into the other scale. Remember, these are a 3.5 watt set. They're not a 4 watt radio. So, as I say, the service manual says anything between 1.7, from 1.7 onwards, and right up to 4 is okay. And at the moment we're on about 3.1. And as you've seen the demonstrations before, it makes so little difference. These have got really punchy audio. And we have got 3.5 watts. And when this cools down, probably be about 3.7. Well, I'm glad that works so nicely. So now we've got that at full power. What does the meter read? Well, it says it's over 4. So we'll just drop that back because I don't want to be that generous. And remember, this is only relevant into a dummy load. If we put this on an area, it's going to either not read much or read a lot. It's still doing 3.5 watts. So let's see if we've got, I'd like it to be within 0.1. I'm going to let this cool down before we go any further on that, because it's not going to be fair to put that reading down when I've been tuning that up. So we'll just do a quick check. It's possible the control there is dirty, so first of all we'll clean that. That's the deviation control. Waggle that around a bit. It's just possible that the audio which is missing is just that. Wallow, 1 2 1 2 wallow, and that's exactly what is the problem. So put our monitor receiver on. Setting 1 2 3 4 5 5 4 3 2 1. So there's nothing wrong with it. It's just dirty control. So we'll now put this on our meter behind us because we can't trust this Marconi one. So we'll just plug the radio into the quartz lock test set behind me. 282A. Let's do a quick check. Wow, it's absolutely spot on. So our Marconi set is actually playing ball with us. Must say that 9 times out of 10 it is, but I just need to double check. Just fine tune that. Now we know we can trust it. Wow, that'll do nicely. Good. So we've got that nicely transmitting. We know it's receiving beautifully, but we're going to go through it. So here's the thing, they're not normal, are they? So let's put the oscilloscope onto the inset picture. It's not the normal detector arrangement, it's not the normal clever chip arrangement. So there, what we've gained on the detector there. I'm going to now go to synad. I think we'll take it to 6 rather than the usual 4. So that's tiny bit better. No change there. A little bit there. Tiny bit there. Quite a bit there. Let's drop the attenuator. Back to that one. Let's look at the shape of that on the oscilloscope. And that looks right. I think we're done, folks. I say it's an unusual arrangement. I'm going to have to put the lid on this phase lock loop cover. Or is that going to cause a problem? Yeah, I'll put the lid on, I can always take it back off again. I'll just twist one of these instead of both. Right, I just want to check it's still on frequency, or somewhere about. Yep, it's not moved at all. Good, so now we'll read off the synad. So, for 12 dB, oh, we're not even showing it yet. For 12 dB, we now have come down a fraction. We've now got 0.53, which is inferior, but that's because we've sorted the detector out. At 10 dB, got 0.46. I won't be surprised this one hasn't improved. Yes, so that's where it's gone. 0.84 on 20. So as we've changed the detector, we've lost some of the sensitivity, but the received audio will no longer be as garbled. We've lost noise. So that's well under the manufacturer's spec. Squelch. What shall we do? We'll do the meter. So that should be 9. It's changed slightly from where it was before. That's the wrong one. It's the front one. It's now bang on the 9. We did the RF meter. That's now reading 4. You know the set's doing 3.5. Squelch. So squelch to full on the radio. Let's put the attenuator up on this screen. So when I turn the attenuator to 100 microfarads, I want the squelch to open, which it doesn't. So it's that preset there. So now opens at 100 microvolts, and let's see where the sensitivity is at the other end. So set threshold on the radio, so put the signal generator back on. 0.54. So that's much better around scratchy corner, and 100 microvolts there. So we've now got 2.2 to 2.5 kilohertz, and let's have a look at yeah, you can't adjust low power on these, can you? Let's have a look where we are with the transmit power. Now I've been out of transmit for a couple of minutes, so we'll go over to the main meter. We're on channel 20. Let's key it up. So our 5 watt position is there. .5 on channel 20, 3.5 on channel 40, and 3.4 on channel 1. So that's brought it up a whole watt. Back to channel 20. Display is still working, but we're not sending it back like that. Low power. Interesting. It's now 200 milliwatts. It was 300 milliwatts. And the transmit current on full power is 915 milliamps. So as far as the radio goes, we're done. We'll put it on the aerial. We'll have a flick round. Then we can just see what happens. And then I can choose whether I publish the video at this point or whether we do the display.
Graham, it's a big tribute. Radio about Mr. Mutt or Melbo?
Well, Nana, Roger.
No, thank you for your input.
19 a Roger.
No.
Well, we're not going to get that, are we? But the burner brigade from Nottingham.
Don't do it, take the piss.
It's 5 o'clock on Saturday. Okay, so I'll leave it at that for now, and
Anyway.
yeah, that's right.
What's the crack, Graham? What is occurring in your life tonight? I need to know.
Right, so before we start putting this back together, we've actually done this. I ended up having to change the flexitrack. The first display board we tried didn't work off a scrap set. So what I've done is to take a display board off a working set of mine, and I'll sort that out later today. Do you remember we were sent from Alan a Fidelity 1000 which had got a football themed front on it? Well, I did buy a front in for that. So what I've done is taken the display board out of that set. And one of the problems, if you look at these, this is the one that's actually come out of this, you really need to be taking the whole channel selector thing out, because to just change the display board, you've got 7 plus 15 wires to disconnect, whereas if you take it out between the radio and this board, you've only got an 8-way flexitrack. But try as you might, these flexitracks are so poor that they break coming out. So what we've ended up doing is to cut 2 flexitracks in half, so we've got 4 and 4 giving us the 8. So you'll see, there we are. It's all in, it's all done properly, but we've had to split it in 4 because I haven't got these flexitracks. The other thing to do is to simply put 8 wires between, like you get in most sets. So I say most sets, certainly with Maxon ones. Where's there a Maxon? So with this Maxon built radio, you've got it just hand wired with 8 wires. So the trouble with these flexitracks is it's effectively sellotape against sellotape with the wires in between, and it's just so easy to break. These are multi-strand wires, but they're as thin as anything, and there's quite a lot of stiffness to the assembly, and this is why the print pulls away. And you can see how many pieces of print had come across that one. So they're all in the same boat. That's the trouble. You do not want to disturb the display department on these radios if you can at all avoid it. So that's brought this one back into operation. Hopefully it powers up. It does. And if I just borrow the knob back. So we ended up doing it twice. And the second time I had to just change the flexitrack between the board and the radio because it was just dying a death. So there we go. That is this chap's a long way away. You can't have things which are going to be unreliable. So that was the reliable way to do it. So I'm going to have to put the screen plate back on this. I'll go and do that in Mr. Chippy's workshop while he's not looking, and then we can draw this to a close, because as you know, we're tuning the radio, we're just waiting for the display to be sorted. Okay, so that's it. Got the screen plate back on. You'll notice they don't quite go on square. As an insulator, you peel this cardboard off and then glue it back on. Using Bostik Impact as adhesive. They don't quite go on square usually, the way the feet line up. Got to be careful about that, because obviously it mounts on the earth plane. So I'm going to just check. We're actually working. We're working on channel 20, channel 40, and just check channel 1. Good. So our walkie-talkie is on 31. So we're just going to check 1 2 1 2 1 2. And if we plug a speaker in, At least on this model you have an extension speaker socket. You haven't on all of these. Testing 1, 2. Testing 1, 2, 1, 2. Excellent. Right, the front. It's not the most unbattered one. So the idea is you've got to manipulate the meter to kind of sit in the right place. So we're in at that end. Not quite in at this end. Oh well, I'll just screw it together. Yes, I meant to tell you about this as well when we took it apart, because the first thing we do is unsolder the speaker. But this hasn't had the speaker unsoldered, and we've actually got a situation where the tag board has been ripped away from the actual speaker. So I think we'll put some tiny screw in that and hopefully solder those back on, and hopefully it'll work. So we'll do that first. Right, so we've returned 2 hours later. So I used the Bostik impact adhesive on the speaker between the metal bit and the insulator. We've soldered the wire back on, tested it with a multimeter, and it still works. But as a belts and braces thing, because I'd like to have left it overnight before doing anything, I've also used the hot glue gun. I've just done that 5 minutes ago, so that's still going to be tacky. So we're doing a belt and braces there, so I'm relying on the Bostik, which is something I can trust, and then we're going to use the hot glue just so I can work with the radio immediately. So hopefully that's staved off having to put in an inferior speaker. And the trouble is, the new speakers are about £5. The ones I'd like to use are about £16.50, and they're still not even the quality which were in originally. So there you are. Don't know which is positive and negative. It doesn't really matter, but will red be positive, will red be negative? See if that is, yes, that's the negative. Do the same test with that, and it doesn't beep. So it's the colours you'd expect, and positives to the right and negatives to the left. Just going to tin that. Put it lower down so there's less strain at this point. The other thing I said I was going to do is just apply some solder to this can. It's just in case he uses it mobile and it generates microphony. Again, it's a belt and braces thing. I mean, these, I don't even remember if these sets do suffer from microphony, but this is just to stop it before it happens. There we go. very carefully put that back. And we'll just check there's some transmitted audio. Testing 1 2 1 2 1 2 1 2 1. There is. So take it off the test gear. Put it on the roof aerial. You can put the squelch on as a treat. And let's listen to the bleed over. One Anna, Roger. Right, well there we go, we'll leave it out doing on the air test. So it's taken a lot of time, I think 6 hours have gone into this one. Mr. Chippy had it on for 45 minutes as well while he was doing what he was doing with it. So we're just putting it back together, and then it started with dry joints. You don't normally get dry joints on this. So I went over some kind of suspects, and it seems to be working. But when they're going a long way away, you don't want things to be iffy. Right, at the end of the day, it's 40 years old. So before we sign off, turn the squelch up a bit. Before we sign off, there's two things which I want to do probably in the next few days, or I'm certainly going to do this in the next few days. One of our overseas readers has mentioned that the advertisement I was looking for, you can't lick a stick, talking about the fire stick, with the lady looking quite sexy on the back, was April 1981. So of course that's before there was CB was legal, and I'm dead against them showing illegal stuff on these things, but there you go, it's up to the time. And the other thing is, we played the cassette tape. My friend David's got one which was produced for Radio Mobile by Dave Lee Travis, and I think he says he may be able to copy that for me. Then we've got two American records. This one's in a sealed packet from 1976. Just take picture in picture off because that's interfering with where we are. So you'll be able to talk to that lorry once you've done this 1976 record. And then this used record has this nice lady with her base station in the kitchen. She ain't got anything like the clutter I've got. She's talking to this geezer in the car. So, there we are, it's two American records. So, if you remember, the cassette tape we listened to was frightfully British radio announcer. So, I'm expecting these to be fast-talking Americans with an extreme accent, so I'll see whether I'm right. But there we are. The interesting stuff of the time, and we'll put those on the record player and do exactly what I did with the cassette tape for you to all enjoy. I don't think there's going to be any copyright problems with the kind of material which is on here. So there you go, thanks for watching the Fidelity 1000. I say that you may not like them, but this customer thinks the world of this with it having very much sentimental value. Thanks for watching.